One of the first things we usually want to know about a numerical variable is where it centers. When we describe a value as typical, we are really asking a practical question. If we had to summarize this entire group with a single number, which number would best represent it? In this video, we explore 3 common measures of center, the mean, median, and mode, and consider when each provides a sensible description of what is typical. A good measure of center should capture the central tendency of the data without being overly influenced by extreme values. However, no single summary works best in every situation. The best notion of typical depends on the shape of the distribution, the presence of outliers, and the context of the data. The 3 most common measures of center, mean, median, and mode, answer the question of typical in different ways. The mean of a sample, often denoted x bar, is the sum of all observations divided by the number of observations. If you imagine placing each data value as a weight on a number line, the mean is the balance point, the location where the line would balance perfectly. Formally, for sample values x1, x2 through xn, the mean is equal to the sum of the sample values divided by the sample size n. Because the mean uses every observation, it incorporates all available information and is mathematically convenient. However, this same feature makes the mean sensitive to outliers. A single unusually large or small value can pull the mean away from where most of the data lie, making it a poor description of what is typical. Florence Nightingale is well known for her work in improving hospital conditions for British soldiers during the Crimean War. One dataset she examined recorded outcomes for soldiers treated in hospitals in Crimea and in Scutari, Turkey. The data contains the number of soldiers hospitalized in various regiments and the number who died. Consider the number of soldiers who died in Scutari for the first 5 regiments. The mean is the sum of the 5 values, which is equal to 480 divided by the sample size of 5. This equals to a mean of 96. At first glance, 96 seems like a reasonable typical value for these data. Now suppose a 6th regiment is added with 500 deaths. The sum now jumps to 980 and the sample size is now 6. The sample mean is now 163.3. Does 163.3 feel typical for this group? Clearly not. Most regiments had death counts well below 200, but the single extreme value dramatically inflates the mean. This example illustrates how outliers can make the mean misleading as a measure of center. For another example, consider annual household incomes in thousands of dollars for a small neighborhood. Most households earn between $45,000 and $65,000 per year, but one household earns $420,000. The mean income is $91,500. A typical income of $91,500 does not reflect the reality for most households in this neighborhood. The single high-income household pulls the mean far above where the majority of incomes lie. This is why average income statistics are often criticized. Because of its sensitivity to extremes, the mean is sometimes modified to reduce the influence of outliers. The trimmed mean removes a fixed percentage of the smallest and largest observations before computing the average. For example, a 10% trimmed mean drops the lowest 10% and highest 10% of values, then averages the remaining data. This approach provides a compromise. It retains much of the information used by the mean while reducing the impact of extreme values. The mean is a powerful and widely used measure of center, but it answers the question of typical only when extreme values are not overly influential. When outliers are present or when the distribution is strongly skewed, the mean can give a distorted picture, motivating the use of alternative summaries such as the median or trimmed mean.